In the previous two videos, we have looked at what is oxidation number and how to detect redox processes. Based on those, now we are going to balance redox reactions. Let us take the reaction that in acid medium dichromate ion Cr2O7 2- reacts with ferrous ion Fe2+ to form ferric ion Fe3+ and Cr3+ ion. The first step is to write half reactions. We have to focus on the two elements, chromium and iron. What happens to iron? It is converted from Fe2+ to Fe3+. Let us look at the oxidation numbers. It increases from +2 to +3. Therefore, it is an oxidation process. The second half reaction is about chromium. Dichromate ion Cr2O7 2- is converted into chromium 3+ ion. Now we are going to assign oxidation numbers to chromium both on the reactant side, that is left side, and on the product side, that is right side. It is +6 on the left side and it decreases to +3 on the right side. Hence, it is a reduction process. The next step is to balance all the atoms other than hydrogen and oxygen. In the first half equation, there is no hydrogen or oxygen and it involves only iron. And iron is automatically balanced. Whereas in the second half equation, to balance chromium, we have to make 2 Cr3+ on the right side. The second half equation has 7 oxygen atoms on the left side. Rule number 3 says balance oxygen atoms by adding water molecules on the opposite side. There are 7 oxygen atoms on the left side. Therefore, we are going to put 7 H2O on the opposite side, that is right side. Now we have balanced oxygen. The next problem is, what about hydrogen? Rule number 4 says balance hydrogen atoms by adding protons. All of you know that protons means H+ ion. The second half equation in that there are 7 H2O on the right side of the equation. Therefore, to balance hydrogen, we have to include 14 H+ on the left side of the equation. Now hydrogen and oxygen is also balanced. The next challenging problem is regarding the charge. In the first half equation, the charge on the left side is +2 and on the right side it is +3. And rule number 5 says balance the charges by adding electrons. So if we add one electron to the right side of the first half equation, the problem of solving the charges is solved. It is very simple here. Whereas in the second half equation, the net charge on the left side is +12. Since it is 14+ due to 14 protons and 2- due to the dichromate ion. And that on the right side is +6 since there are 2 chromium 3+ ions. Therefore, if we add 6 electrons to the left side of the second half reaction, the charges are balanced. The last step is cancelling the charges. How to do it? Verify that the electron appears on opposite sides in the first and second half reactions. Then only we can confirm that we are proceeding in the right direction. Is it so in our equation? Let us check. Yes, in the first half reaction, electron is on the right side, and in the second half reaction, electrons appear on the left side. Therefore, we can confirm that we are proceeding in the correct direction. Next one is equalizing the number of electrons by multiplying with an appropriate number. Since there are 6 electrons in the second half equation, the first half equation is to be multiplied by 6. When we do so, we will get 6 Fe2+ giving rise to 6 Fe3+ plus 6 electrons. Next one, cancelling the charges and adding both the half equations. What are the common terms here? Nothing but electrons. So when we cancel the electrons, 6 electrons on the first half equation and in the second half equation, and then when we add, we will get 6Fe 2 plus 14H plus Cr2O7 2 minus, giving rise to 6Fe 3 plus 2Cr 3 plus 7H2O. This is the final balanced redox reaction. Let us look at the next reaction. Copper metal reacts with concentrated nitric acid to form copper 2 nitrate and nitrogen peroxide gas is evolved. The unbalanced ionic equation for this is Cu plus NO3 minus, giving rise to Cu2 plus NO2. The two half reactions are, the first one is Cu giving rise to Cu2 plus. Here the oxidation number of copper increases from 0 to +2. Therefore, it is an oxidation half reaction. The next one is, second half reaction is NO3 minus giving rise to NO2. Let us assign oxidation numbers to nitrogen. It is +5 on the left side and +4 on the right side. There is a decrease in oxidation number, therefore it is a reduction half equation. The next step is balancing all the atoms other than oxygen and hydrogen. The first half equation involves only copper and no hydrogen or oxygen, and copper is automatically balanced. Coming to the second half equation, here also nitrogen is balanced, no problem. The third step is balancing oxygen. For this, we have to include one water molecule on the right side of the second half equation, since the number of oxygen atoms on the right side is only 2 compared to 3 on the left side. The next is, fourth step is to balance hydrogen. For this, 2 protons are to be added to the left side of the equation, since the right side contains 2 hydrogen atoms due to the presence of 1 water molecules. So if we add 2 protons on the left side, hydrogen is also balanced. So the problem of balancing oxygen, hydrogen, everything is over. The next challenge is balancing the charges. To balance the charges in the first half equation, 2 electrons are to be added on the right side. In the second half equation, the net charge on the left side is +1 and it is 0 on the right side. Therefore, 1 electron is to be added on the left side of the second half equation. To equalize the number of electrons, either one of the half equations or both the half equations are to be multiplied by appropriate numbers and then added. Here, the second half equation is to be multiplied by 2, since there are 2 electrons on the right side of the first half equation. On doing so, it becomes 2 electrons plus 4H plus 2NO3 minus, giving rise to 2H2O plus 2NO2. Cancelling the only common term, that is electron, we get Cu plus 4H plus plus 2NO3 minus, giving rise to Cu2 plus 2H2O plus 2NO2. So we have arrived at the final equation. You would have observed that H plus ions appear on the reactant side in the final equation since it is carried out in the acid medium. Students may think that it is difficult to balance redox reactions, but don't be afraid of. By constant practice, it will definitely become easier. Let us meet in the next video.